Problem A3. Throughout this problem, the inertial rest frame of the rod will be referred to as the rod's frame, while the inertial frame of the cylinder will be referred to as the cylinder's frame. A rod is traveling at a constant speed of v equal 4/5 of speed of light to the right relative to a hollow cylinder. The rod passes through the cylinder and then out the other side. The left end of the rod aligns with the left end of the cylinder at time t equals 0 and the x equals 0 in the cylinder's frame, and time t0 equals 0 and the x0 equals 0 in the rod's frame. The left end of the rod aligns with the left end of the cylinder at the same time as the right end of the cylinder aligns with the right end of the cylinder in the cylinder's frame. In this reference frame, the length of the cylinder is 15 meters. For the following, sketch accurate scale diagrams of the motions of the ends of the rod and the cylinder on the graphs provided. The horizontal axis corresponds to x, the vertical axis corresponds to ct, where c is the speed of light. Both the vertical and horizontal grid lines have 5 meters spacing. Question A. Sketch the whorled lines of the left end of the rod RL and the left end of the cylinder CL, right end of the rod RR and the right end of the cylinder CR in the cylinder's frame. Question B. Do the same in the rod's frame. Question C. On both diagrams clearly indicate the following 4 events by the letters A, B, C, and D. A. The left end of the rod is at the same point as the left end of the cylinder. B. The right end of the rod is at the same point as the right end of the cylinder. C. The left end of the rod is at the same point as the right end of the cylinder. D. The right end of the cylinder is at the same point as the left end of the cylinder. Question D. At event B, a small particle P is emitted that travels to the left at the constant speed Vp equal 4/5 of speed of light in the cylinder's frame. Question 1. Sketch the whorled line of P in the cylinder's frame. Question 2. Sketch the whorled line of P in the rod's frame. Question E. Now consider the following in the cylinder's frame. The right end of the rod stops instantaneously at event B and emits a flash of light, and the left end of the rod stops instantaneously when the light reaches it. Determine the final length of the rod after it has stopped. You can assume the rod compresses uniformly with no other deformation. Any computation that you do must be shown on a separate sheet of paper and not on the graphs. Graphical work that does not have supporting computation might not receive full credit. Here are presented 2 sheets for your diagrams. Solution. Here we presented solution graphs for this problem. The graphs are shown here, where the yellow line is the particle P and the green line is the flash of light. The final length of the rod is simply the distance between the line CR and the intersection of RL and the green light. i.e. 25/3 meters. There is no need to apply length contraction as we are already in the rest frame of the rod at this point. Nonetheless, the way we have chosen to stop the rod has squeezed it shorter. That was solution for problem 3.